Mr. Allen.
It's fine.
All right.
Yeah, so we haven't been able to get everybody over here because it's like 12 at night.
And also the fact that it's a different country.
Right.
You know?
How many countries are we at Dabble right now?
We
How
are
many
3
continents
countries.
you mean?
Oh,
Continents.
We're full 3 continents.
That's true.
We're intercontinental company already.
Where do we have people from?
We have people from Asia, Europe, and North America.
Yeah, that's crazy. And the people working on facial rec are from basically
Asia,
everywhere.
Europe, and North America.
Dude, it's painful to get this done. But we have this broad conjecture. Well, not conjecture, a solution, I would say, to actively engage with, beat Apple, Meta, and Google at facial recognition. And the core techniques to do that will be explained by AJ and Adit. So let's go. How do we get this done, dude?
So we need to use something that Apple, Meta, and Google do not have. So clearly, brute force isn't the way to go. There needs to be something innovative done here. We need to use some data that these 3 don't have, which is social network data and location data. So, AJ?
Yes. So, one of our most interesting ideas that has been vetted by many industry AI leaders is that we are going to how does facial recognition work in the first place? You get a face, you do something called an embedded model, which converts the face effectively into numbers. And the more similar the numbers are, the more likely it's the same face. It's a very simple algorithm, but at the end of the day, we just have to get good numbers, and we have to figure out which numbers are the same or like close enough. And unfortunately, just picking like a random threshold for what is close enough is just not good enough, because for some people you just don't have enough images, and for some people you have to be images from 2 different ages, and it's quite difficult for AI to just understand the context in which these images exist.
Do we want to show them what we already implemented on facial recognition and what some of the challenges there are? I think the biggest problem that we have right now is embeddings on facial recognition systems.
The biggest problem we have right now is clustering.
What does clustering mean?
So, as AJ was saying, deciding how close is close enough, that is clustering. So, we have a bunch of numbers or vectors, series of numbers, and we need to group them into clusters. So, into clusters of points or clusters of vectors. And one cluster is supposed to be one face. And ideally, each face has its own cluster, and we've perfectly segregated all faces, but that is not so easy.
Can we show them what we have on the app right now?
So the app has a very simple UI for face selection. All you need to do is there's an old version of the app. So do you want to show a newer version?
Yeah, let's just pull up the new version. I think, can we pull up the new version? AJ will explain the rest of the... Oh, he probably already has it. Okay.
So this is the newest version. In this, you can just click which faces you want, and magically it'll just filter the background.
Yeah.
But
let's just go into the facial aspect of it. If you look carefully, a lot of the faces are actually of the same people again and again. So you can see Adit over here once and over here again, right? So the biggest issue is how do we avoid this duplication? And we actually have a very tangible solution, but moving a bit faster on over there, the 2 data points that we leverage that these other guys just simply don't have access to is location data and social graph data. The basic logic for this is very simple. If AJ is sending a lot of images to Adit, the odds are Adit has a lot of images. If they are very close friends, let's say the distance of friendship between them is X, and between Adit and Geet is Y, and let's assume X is much smaller than Y, then the odds are that AJ has a lot of photos of Adit, and Adit has a lot of some photos of Geet, and they probably have some photos among them. So we assign probabilities based on how closely they're related, and use kind of that metric to figure out how to unionize these clusters.
Okay, so that's the priors. The priors is the initial probability we assign before we look at the faces. Then we have 2 variables we need to use. The first one is your friends. So how will we use your friends to better deduplicate the clusters? What we're going to do is each person will create a fine-tuned model that's able to distinguish their friends' faces specifically. That model will get uploaded to the cloud as a delta from the original model, and we will use that to very quickly create a consensus polling mechanism, which will use ELO ratings to figure out which models to give higher weights to. That's going to be able to figure out, are these 2 faces the same or not? That's how we're going to use your friends' galleries to make specifically fine-tuned models just for you and your friends.
And tell me, how would this not be privacy preserving? What's going to go on with that?
So to make it privacy preserving, the models are only going to be stored on the cloud, and we're going to give minimal data about how we came to the conclusion whether these two images are duplicates or not. So by minimal information, we need at least a few models, and there should be many of your friends who have an image of this person. Otherwise you will just return undefined. Like, we'll just not tell you that these are the same faces or not.
So you're saying that we will wait until somebody has multiple friends where there's enough, let's say, noise,
Yes.
to effectively use everybody's data to get a better sense of who one person individually is. And if we don't have that, we will not, frankly, update their clusters. So in some sense, we're completely making sure that privacy is maintained.
And the last idea is using location data. Of course, we can't just randomly use your location data because that's very privacy violating. But what we can do is to use the fact that images are meant to be shared. Now, when you share an image to a group, at the time you're at an event, right? Just by the fact of knowing the edges that are used while sharing, we instantly know the people who are in that event. That alone significantly reduces the number of people we have to cluster. And by taking advantage of those priors, we are able to create a very, very efficient algorithm for clustering. Because the amount of faces we have to cluster is just much lesser than Apple or Google does.
So how many would Google have to do or Apple have to do for them to get to where they
How
were?
many pictures do you think, how many different people do you have in your pictures? Do you want to guess?
Hundreds
1,000?
to thousands, probably more.
Even strangers might be in your pictures.
Exactly.
Right? But how many people would be at an event? Maybe 30, 50?
Even lesser than that. How many relevant people would be at the event?
Yeah.
10, 5.
Exactly.
In facial rec, do you really,
Not only
do
that,
you really
when
care
an
about
image is
clustering
shared between
strangers?
different people, the results can also be shared. That gives us an advantage of using everyone's specifically fine-tuned models on their friends specifically. And when you're sharing the images, not only is that shared, the facial recognition results are also shared, but only for the people who are mutual friends to make it privacy preserving as well.
Wow. So in some sense, if I were to give a high picture of it, on a very mellow level, it's like how Waymo operates, where you have mini models in cars and then mega model in the cloud, and then the weights are updated to the cloud. Except this is hypercharged based on how closely related your friends are. And if, let's say, that some of the cars are extremely closely related, it just works very, very well for everybody. Would that be fair to say, or have I messed this up? I've messed
good
this up.
enough.
It's
fair
good
enough.
enough. It's fair enough.
Yeah.
Interesting.
Searching through just your friends is way better than searching through literally everyone in your gallery, right? And generally, people don't really care about strangers being recognized as people in their photos than they do about their friends being recognized.
Of course. So tell me, so if we are at X and Apple is at 100X right now, after what are the constraints to implementing what we need right now? And where will we be after we actually end up implementing it?
So we have intelligent people who are doing AI for quant companies who are helping us build the system. We are reading all sorts of research papers, reading about consensus mechanisms to convert unlabeled data to labeled data for training. And we're going to use these algorithms to best make sure that the fine-tuning is done on valid data. Because one of our biggest constraints is the fact that we are training on unlabeled data inherently. So if the data itself is calculated wrong, then our model itself will fine-tune on wrong data.
So how much does pre-fine-tuning even cost?
So the advantage of our advantage is the fact that we are only fine-tuning. We don't have to pre-train. And pre-training is one of the more expensive parts of AI training. We are going to be using state-of-the-art models and fine-tune them for our purposes. And we're going to need money mostly to test out all different ways to fine-tune. We're going to test out different number of images, different types of images. We're going to see which ones work, which ones don't. And we're going to effectively try out different algorithms to figure out what is the best ELO-based polling mechanism to use and to make sure that our algorithm can beat Apple.
What does that mean? So if we're at %X and again Apple's at 100X, where will we be after this is done?
I'm hoping that let's say if Apple has a 10% error rate, we want a 3% error rate, 2% error rate.
And we're very certain that we can get it with these two additional variables.
Yeah, with the priors that we've got, it's definitely possible.
How long would we have to do this fine-tuning for?
So fine-tuning, we don't have to personally fine-tune it. We just need to find algorithms that will help fine-tune models on device. And to do that, we're going to have to do a lot of testing, try out a lot of innovative algorithms and just keep on doing it until we beat Apple. We're not going to stop.
Very good, very good, very good. Tell me, so even when Apple does it, they have to have something running overnight on the phone, right?
Correct. Apple needs to cluster your face. Apple requires your phone to be on charge and runs their clustering algorithm all night in the background.
And how often do they do
successfully
this?
cluster.
All night, every day. Every
night.
day you put your phone on charging, it runs the clustering algorithm. That's how much it matters.
Oh wow! And how much? How we expecting to beat that?
So, I mean, we just said it. They don't have the priors that we do. Our job
They
is
are going to cluster at night, we're going to poll your friends at night. And we're going to win.
yeah.
Oh, so
Polling
it's just
friends,
infinitely
definitely.
lesser compute also.
Correct. Apple actually requires 3 different clustering algorithms to do their job. The first one they cluster using not just the face but also the upper body, and after that they do this all night clustering, and then they do something called linkage clustering, which is their heuristic designed to merge duplicate faces.
And I think also I remember talking about how before we get like a large set of close friends with each other, we could probably use something like the cloud to run some of these computations.
Yes, so the models are going to be run on the cloud, and the clustering is, we're hoping that clustering is not too much of a bottleneck, but if clustering ever turns out to be a bottleneck, we're also going to start aggressively clustering on the cloud.
And that'll only be up until a point where you have a lot of friends on your app.
Yes, when we have a lot of friends at
How
that
many
point,
is lot of friends? How many would lot of friends be?
I would say if you have 10 friends with 1,000 photos, that should be good enough.
1,000 total photos.
1,000 photos of like you.
1,000 photos of you. So if we have about 10,000 photos total from any points, including
Yes.
your parents.
10,000 photos is more than enough to be able to figure out who you are effectively.
Interesting. So I
Who
guess
you and all your friends are.
yeah, and I guess if you include like parents and siblings, you already have like thousands over there.
Exactly.
And by virtue of it being initially a photos app, I don't think that should be too hard to get.
Yes.
So that becomes very interesting, and we don't have to wait overnight. This will be done pretty much instantly.
Yep. This is way faster.
So on first download, let's assume I have my parents already on the app. Let's say all of us are on the app. What would the n+1th person? How much time would it take for us to identify them, or do we already know who they are?
For mutual friends, that it's a little bit tricky because we don't really want to give away information about your mutuals, but the moment you add them as a friend, we're going to instantly start polling your friends. We're going to make sure that the images of your new person is instantly created on your phone. But sadly, I don't think it's possible for us to get images of a mutual using the polling algorithm. We have to be very cautious of people's privacy because that's the image we want to set. Because we're not the ones using ads, we're not the ones using data collection. We are the ones using transparent, honest methods to just get people to chat.
That's true. We just want to help people to chat. This is not even the social network Dabble. This is just the one aspect of how we navigate through the app.
Social activity.
But more importantly than that question, I think I want to really ask: if I have 10 friends already, how easy would it be for the system to identify the 11th friends' face? So when they first download the app, how much more time would it
This is
take?
assuming the 11th friend is already in your gallery.
Yes.
right?
Yes. So if you add your contacts as friends, it should be almost instant.
Oh wow! So you're saying if I have just 10 friends, getting the 11th person requires really zero work.
Effectively, yeah.
Effectively for them, facial recognition should be instant for all of the friends.
So you're saying after we have a set of clustered users in let's say one college, not even one college, like one class,
Yeah.
then expanding on becomes instant.
All they need to do is just poll you. That's it.
Very interesting. So I guess that pretty much sums up how novel our facial recognition approach is, and we should probably have a white paper with hardcore experimented results that we've implemented on our system out in the next couple of weeks. Cool. That's it for this pod.